I'm Ariel Cintron Arias, and I'd like to first start by thanking my collaborators on this project, Ryan Nevens and Calvin Purvis. And what I'd like to discuss with you over the next few minutes has to do with capacity building, and specifically with an emphasis on mathematical modeling by producing a number of STEM professionals that would have some skills on the context of simulation, computer simulation, data analysis, and mathematics and statistics. So, as I said, many of you already know me. I have a degree in applied mathematics. You know some of my research interests that are at the interplay of describing processes with mathematics or statistics and then using data. I apologize because the first two slides here in the horizontal axis have a lot of names that are being cut off there, but really there's only one part of these graphs that is more relevant. And what we're seeing here is the percentage of professionals with undergraduate degrees in mathematics across the nation among all possible disciplines. This is a snapshot of the year 2012-2013, and this is my motivating slide here to tell you that 1% of people obtain undergraduate degrees in mathematics. This is at a national level across all disciplines. If we take a look at the number of graduates from East Tennessee State University, and then look again at the percentage of graduates obtaining a bachelor's degree in mathematics, then this is completely coincidence. It happened to be the same with a precision of 1 decimal digit. It's still 1.1% of ETSU graduates walk away from here with an undergraduate degree in mathematics. Now, among these groups, if we were going to take a closer look at a subset in the disciplines that are considered science, technology, engineering, and mathematics, the so-called STEM disciplines, then at a national level, this is what the distribution looks like. This is still number of undergraduate degrees awarded in 2012-2013, and at the national level, among STEM disciplines, 3% of STEM professionals have undergraduate degrees in mathematics. And similarly, or in analogy, we look at the same distribution, the same type of subset of ETSU graduates, then we see that the percentage of mathematicians, these are the new, fresh mathematicians out of the production line in the year 2012-2013, is 5%. So you may have, you may have some comments or some ideas. I would say that this, in fact, reflects, these are very small percentages of people obtaining undergraduate degrees in mathematics. But I think in a way it also reflects, there's a natural distribution of how people decide, find themselves suited for one profession, for one career, So mathematics is a substantial commitment to commit to mathematics or chemistry or whatever the major is. So the fact that we have among STEM disciplines between 3 to 5% and across all disciplines about 1%, I think simply reflects, that's simply the natural state of the natural distribution in terms of choosing a career path that is well suited. And so with that in mind, the motivation of my message today is that there is room for growth in undergraduate mathematics education when it comes to, I think as a professor of mathematics, I think it always is important to have a goal to increase the number of mathematics majors. But realistically, even with that those efforts will be to change that 1% to 2 or 3%, is substantial. Or even changing the 3 to 5% to say the double, 6 to 10% is still substantial. So my message today is, well, There is certainly efforts that could be deployed to increase the number of majors, but today I'll be speaking about increasing the number of mathematics minors with a particular emphasis.